Welcome back to the deep dive. Ready to explore something new?
Always.
This time, we're taking a deep dive into the world of bismuth.
Bismuth, huh?
Yeah. You probably know it from Pepto-Bismol.
Ah, right, for upset stomachs.
But trust me, there's a whole lot more to this element.
Oh, I bet. What kind of sources do we have today?
We've got excerpts from the Royal Society of Chemistry's website, there's the Wikipedia page on bismuth, and an article all about its applications.
Sounds like we've got a lot to uncover.
We do! We'll be unearthing bismuth's history, its unique properties, like, did you know it can make spoons vanish?
Make spoons vanish. Now that's intriguing.
Right. We'll cover that, and of course, we'll explore its many uses.
Let's dive in then.
So where do we even begin with bismuth? I mean, it's been around for ages.
It has. Our sources say it was known since ancient times.
Yeah.
But there's a catch.
A cat.
People often mistook it for lead or tin back then.
So some historical objects thought to be made of lead or tin.
Could actually be bismuth.
I will see,
Isn't that
yeah.
fascinating?
Yeah. Talk about hiding in plain sight.
Exactly. It wasn't until the 18th century that scientists truly recognized it as a separate element.
It's amazing how long it can take to, fully understand something.
Absolutely.
Yeah.
But once bismuth was identified, people started discovering its incredible properties.
Like its diamagnetism.
Precisely. Bismuth is exceptionally good at repelling magnets.
Really good.
One of the best, actually. More so than almost any other element.
So if you held a strong magnet near bismuth,
It would actually push away from the magnet.
that's wild. And on top of that, it's got this incredibly low thermal conductivity.
Right. Most metals conduct heat really well. But bismuth, it's the exception. One of the least thermally conductive metals out there.
So it's like the odd one out in the metal family.
In a way, yeah. And there's one more curious fact. Bismuth actually expands when it freezes.
Wait, doesn't most stuff shrink when it freezes?
You'd think so, right. But bismuth does the opposite.
Hold on, isn't that what water does?
You're absolutely right. Water is another exception.
Okay, so bismuth is an exception to the exception.
Kind of, yeah. And this unusual property actually has some important implications.
Especially when you use bismuth in alloys, right?
You got it. In fact, this very characteristic was behind a popular trick in Victorian times.
A trick. Do tell.
It was called the vanishing spoons.
Vanishing spoons. Sounds like something out of a magic show.
It was a bit of chemistry magic, really.
Hmm.
They would make spoons from a special bismuth alloy.
Special how?
This alloy had a melting point just below the boiling point of water.
Okay.
So when you stirred your hot tea with one of these spoons, it would melt and seemingly disappear.
No way! That's amazing.
Right.
It's like a perfect example of how the melting point of different bismuth alloys.
Determines their use, exactly.
This is proving that bismuth is way more than just a stomach soother.
It is. And speaking of which, we should dive into its applications. Started with its role in medicine,
Of course. Bismuth subceltulate.
the active ingredient in Pepto-Bismol.
Yep. I read somewhere that bismuth is also used in other medicines, like for ulcers.
That's right. It seems to have a knack for treating digestive problems.
Bismuth. The digestive system's best friend.
Maybe so. But bismuth isn't a one-trick pony. It's used in cosmetics, too.
Cosmetics. Now that's a surprise.
Yep. Bismuth oxychloride is a common ingredient in makeup.
What does it do?
It gives things like eyeshadow, lipstick, and nail polish that shimmery, pearlescent sheen.
Oh, so it's like natural glitter.
Exactly. It occurs naturally as a mineral called bismuclite. And its structure helps to refract light and create that iridescent effect.
I've got to say, this is way more interesting than I thought it would be.
Glad to hear it. And speaking of things that sparkle, what about those bismuth crystals?
The ones with all the rainbow colors?
Yeah,
They're stunning. I've seen pictures. They're mesmerizing.
they truly are. And those vibrant colors are due to light reflecting off the oxide layer on the crystal surface.
It's amazing what nature can create, huh?
Absolutely. And here's a fun fact. You can actually grow bismuth crystals at home.
Oh, wow. I might have to try that sometime. But bismuth is more than just pretty, right? It's also used in important things like fire safety.
You're right. Bismuth is a key ingredient in fire detectors, extinguishers, and sprinkler systems.
Why is that?
Well, remember, it's low melting point.
Yeah.
When there's a fire, the heat triggers the bismuth alloy to melt. That activates the safety mechanism.
So it's like a built-in safety switch.
Pretty much.
Now, let's talk about another important application that's becoming increasingly relevant.
Replacing lead.
Exactly.
It's a perfect substitute because bismuth has a similar density to lead.
But with one huge advantage.
It's much less toxic.
Right, so we can use it in things where lead is a concern, like for the environment or for people's health. It's like bismuth is stepping up to be the eco-friendly hero.
I like that. The eco-friendly hero, replacing lead in everything from bullets to fishing weights.
It's impressive how this once misunderstood element is now protecting our planet.
And it doesn't stop there. Bismuth is even being used as a lead replacement in electronics.
This is where it gets even more interesting, because traditional solders, those often contain lead.
They do. And that can be a problem if it leaches into the environment.
Not good.
Right. So there's this big push to replace lead-based solders with bismuth-based ones, especially in things like food processing equipment or plumbing.
Makes sense. Places where toxicity is a big concern. It's like a domino effect. The more we learn about bismuth, the more we find uses for it.
And the more we can use it to protect our health and the planet.
Absolutely.
And, this shift is getting a boost from things like the European Union's RoHS directive.
The one that restricts hazardous substances in electronics?
Yep. That's pushing for more bismuth-based solders and other bismuth materials.
So bismuth is helping make our electronics more eco-friendly, too.
Exactly. But its talents don't stop there. Remember how we talked about bismuth expanding when it solidifies?
I'm still amazed by that.
Well, that property is incredibly valuable in creating alloys with very specific characteristics.
I can only imagine.
This expansion allows bismuth to be used in high-precision casting. For example, in dentistry.
Really?
Yep. They use it to make detailed molds. As the bismuth alloy cools and solidifies, it expands.
To fill the mold perfectly.
Exactly. It compensates for the shrinkage of other metals in the alloy.
That's amazing, and that results in an incredibly precise final product.
Precisely.
And what about those low-melting alloys? What are those used for?
Oh, all sorts of things. Safety valves in boilers, fuses in electrical circuits, even automatic sprinkler systems.
Wow. It's remarkable how bismuth can be found in so many different things, from vanishing spoons to fire safety systems. Bismuth really is the element of hidden talents.
It really is.
So we're back, and I'm ready to learn more about bismuth's more specialized applications.
More specialized? Like what?
Well, I read about its use in nuclear medicine.
Nuclear medicine.
Yeah.
That's interesting, especially since we've been talking about how non-toxic bismuth is.
I know, right? It seems kind of counterintuitive.
It does, but it all comes down to radioactive isotopes.
Oh, okay.
Bismuth has those, specifically bismuth-213. And this bismuth-213, it's got a really short half-life.
Huh. That's kind of odd for bismuth, isn't it?
It is, but that's actually what makes it useful for medical treatments.
Okay, I'm listening.
So bismuth-213, it undergoes this process called alpha decay. It emits alpha particles.
Alpha particles.
Yeah, and those alpha particles, they can be pretty damaging to cells, especially cancerous ones.
So it's like a tiny weapon against cancer.
That's a great way to put it. It's used in something called targeted alpha therapy, or TAT.
How does that work?
They attach bismuth-213 to a molecule that targets cancer cells.
Oh, I see.
So those powerful alpha particles are delivered right to the tumor.
And that minimizes damage to healthy cells.
Exactly.
That's incredible. What kinds of cancer can they treat with this?
It's showing promise for certain leukemias. And researchers are looking into other cancers too.
So bismuth's unique properties are being used for very specific medical purposes.
You got it.
Now, shifting gears a bit, I read about bismuth being a thermoelectric material.
Ah, yes.
I'll be honest, I'm not entirely sure what that means.
Well, in simple terms, a thermoelectric material can convert heat energy into electrical energy.
And vice versa.
And vice versa, exactly.
So you're saying we can use bismuth to generate electricity from heat?
Precisely. A good example is bismuth telluride. If you apply electricity to it, it'll either heat up or cool down.
Depending on the direction of the current.
You got it. And it works the other way, to apply heat to it, and it generates electricity.
So it can be used for both heating and cooling. That's amazing. What's it used in?
All sorts of things. Portable refrigerators, cooling systems for computer processors. You might even have some in your pocket right now.
In my pocket? Really? Where?
Many infrared spectrometers use bismuth telluride detectors.
Infrared spectrometers.
They're used for chemical analysis. And some newer smartphones have those built in.
So my smartphone might be using bismuth telluride.
It's possible.
Wow, bismuth is full of surprises.
It is.
Okay, so beyond nuclear medicine and thermoelectrics, what other fascinating applications does it have?
Well, bismuth compounds are pretty versatile. There's bismuth oxide, for example.
What's that used for?
Specifically, its delta form. It acts as a solid electrolyte for oxygen,
A solid electrolyte.
meaning it can conduct oxygen ions.
I see.
That makes it useful for things like fuel cells and sensors.
So bismuth is contributing to cleaner energy.
It definitely has a role to play. Then there's bismuth germanate.
Okay, what about bismuth germanate?
It acts as a scintillator.
A what?
A scintillator. It's used in X-ray and gamma-ray detectors.
How does that work?
Well, a scintillator is a material that emits light when it's hit by radiation.
Okay.
So when X-rays or gamma rays hit bismuth germanate, it flashes. And those flashes, they can be detected to create an image.
Ah, so that's how X-ray machines and other medical imaging devices work?
Exactly. Bismuth germanate is a key component.
Wow. It's amazing how this one element is involved in so many important technologies.
Isn't it?
What about bismuth in more everyday things? We've talked about cosmetics, but are there other examples?
There are. There's bismuth vanadate. It's a pigment, a really bright yellow one.
What's that used in?
It's used in paints. It's a safer replacement for cadmium sulfide, which can be pretty toxic.
So it's adding color to the world, but in a more eco-friendly way.
That's the idea.
Yeah.
And on top of that, bismuth is even used as a catalyst in rubber production.
Seriously.
Yeah.
It seems like bismuth has a hand in almost every industry.
Well, maybe not every industry, but it does have a wider range of applications than most people realize.
That's for sure. This deep dive is proving that. We've gone from bismuth being a misunderstood metal to its role in cutting-edge technology. And it can even save lives.
Pretty remarkable.
What stands out to me is that bismuth shows how scientific understanding can unlock all sorts of unexpected uses for an element.
I totally agree. It's a great reminder that there's always more to learn, even about something as seemingly simple as an element. By the way, what's resonated with you the most from our discussion?
That's a tough one. But bismuth's low toxicity is really impressive.
Oh, yeah.
I mean, here's a heavy metal that's actually replacing other heavy metals that are more harmful. That's a big deal.
It is. It shows just how much potential bismuth has as a sustainable, eco-friendly material for the future.
Definitely.
And as research continues, I'm sure we'll see even more innovative uses for bismuth.
I'm excited to see what they come up with. You mentioned earlier that you had a question for our listeners.
Oh, right. We've talked about how bismuth expands when it solidifies.
Yeah.
So thinking about that, what innovative applications could emerge in things like 3D printing or microfabrication? Something to ponder.
3D printing with bismuth. That's fascinating.
Right. It could revolutionize so many things.
Imagine the possibilities. We could create such intricate structures, things we can barely even picture right now.
Exactly. We could be talking about, like, tiny bismuth gears.
For micro machines.
Yeah. Or even think about biomedical implants.
With, like, custom-designed porous structures.
Precisely. Bismuth could open up a whole new era of materials science.
It really could. And this brings me to another thought. Bismuth's role in all this sustainable technology we're talking about.
Yeah, it's not just about replacing lead, is it?
Right. I mean, its low toxicity just makes it perfect for so many eco-conscious innovations.
I completely agree. As we move towards a more sustainable future, we're going to need more materials like bismuth.
Materials that are non-toxic, environmentally friendly.
Exactly. And bismuth, with all its unique properties, it's in a great position to help us get there.
It's like bismuth is the unsung hero of the periodic table,
Quietly working behind the scenes.
making our world a little bit better. So, as we wrap up our deep dive into bismuth, what are the key takeaways for our listeners?
Well, I hope they've come away with a newfound appreciation for bismuth.
Yeah, it's definitely more than just an ingredient in Pepto-Bismol.
Right. From its ancient origins to its modern-day applications in medicine, cosmetics, electronics, bismuth has a pretty amazing story.
It does, and it really shows us the power of scientific curiosity, how just exploring the potential of the elements around us can lead to these incredible discoveries.
Absolutely.
Who knows, maybe our listeners will be inspired to, try growing bismuth crystals at home.
Yeah.
Or learn more about the research being done with bismuth.
I'd love that. The more we understand about bismuth, and all the elements for that matter, the better we can use them for the benefit of humanity and the planet.
Well said. Thanks for joining us on this deep dive into the amazing world of bismuth.
It was my pleasure. And as always, stay curious. There's so much more out there to discover.